Welcome. So this question says a force of plus 3I minus 6J plus 2K newtons is used to displace a 5 kilogram object by minus 4I plus 2J plus 4K meters, and then how much work is done by the force. So it's a three-dimensional problem. I'm talking about IJK notation for three-dimensional space vectors. I've got to visualize it, and so basically I can just draw a vector indicating the force, and this would be plus 3I minus 6J plus 2K newtons. Now, how do I get this direction? It's just symbolic. I have no idea what direction it is. I could work it out, but I don't need to. All I need to do is represent that this has a certain direction in three-dimensional space. And then my displacement, I'm just going to draw it with another vector. And I'm going to say this is minus 4I plus 2J plus 4K meters. And here again, I'm just symbolically representing it's in a different direction. And I want to find the work done when this force is displaced by that displacement. And so basically what I do is I say, well, work is equal to the force times the displacement times the cosine of the angle between. I have no idea what the angle between these two guys is, and I don't on the offhand know what their magnitudes are. So what I invoke now is that work is equal to the vector force dotted with the vector displacement. These are the same thing. This is a scalar magnitude value. This is the vector value. This is also a scalar value, but I get there by using the vectors. It's a dot product, which is a scalar product. So now I come to a bit of layout, and I like to, I'm going to say that this is work is equal to, I'm going to say plus 3I added to minus 6J added to plus 2K dotted with, now let's do the force vector, minus 4I added to plus 2J added to plus 4K. I just squeezed it in. Okay. So then how do I do a dot product? And what I do is I take the coefficient of the first vector and multiply it by the coefficient of the second vector. So this would be plus 3 multiplied by minus 4. And that's my first value added to. And then I take this minus 6 and multiply it by the plus 2. And then I take my third coefficient, so plus 2 multiplied by plus 4. There's no vector involved, there are no IJKs involved. Now we simply say, oh, that's going to be minus 12 added to minus 12 added to plus 8. So this would equal minus 24 plus 8, which would equal minus 16 joules. What that means is that the force took kinetic energy out of the system. The work done was negative. So this dot product is amazing. If you think about it, I took two vectors which were anywhere in three-dimensional space, and I was able to work out the scalar product of them using just simple math. I could have worked out the magnitude of the force. I could have worked out the magnitude of the displacement. I could have worked out the angle between them, and then I could have got the same number using this magnitude calculation above. But that would have been a much more arduous and tedious thing to do than what I did here. So very nice technique. And the answer was -16. And there we have it.